All right, welcome to part two of 7.4. In this lecture, we're going to talk a little bit about a pH, which is a measure of how acidic or basic substances are, and also, kind of in general, logarithmic scales. pH is one example of what's called a logarithmic scale. Okay, so this formula that we've got here, pH is the negative log of this H sub 3 0 plus. All right, and log just means log base 10 again. The H30 plus is what's called the concentration of hydrogen in the substance. It's in units of moles per liter. And you don't have to worry about the units or anything here. We're just going to do a little math with this. Um, Generally, H30 plus is going to be a extremely small number, the concentration of these particular ions in hydrogen ions in a substance. Okay, so for example, if H30 plus is 1.5 times 10 to the negative fifth, what's the pH? pH equals what? Okay. All right, and again, notice we're going to use scientific notation here. Um, if we were to write out this 1.5 times 10 to the negative fifth um, longhand, that would be 0.00015. Okay, that exponent minus 5 is telling you that you're going 5 places to the right. Okay, so a negative exponent on your 10 means a very small number. The bigger that exponent is negatively, the smaller the number. Okay, so how do we do the pH? Okay, so the pH of this is just minus log 1.5 times 10 to the minus 5. Okay, now you can certainly just plug this right in your calculator using your base 10 logarithm. Just minus log of 1.5 times 10 to the minus fifth, or type it in with all the decimals if you want. I'm going to do this slightly different, which will give a little bit of a shortcut. Okay. First, I'm going to use one of those properties of logarithms that we looked at last time. When you have a product, you add the logarithms. So log of 1.5 times 10 to the negative fifth is the same as log of 1.5 plus log time of 10 to the negative fifth. Okay, and I still got the minus in front there. Okay. Now, the log 1.5, that I will put in my calculator. Okay, and that's just going to be 0.1761. You can check that out on your own. Okay. All right, and this part here, excuse me, remember when there's no base there, it's base 10. Log base 10 of 10 to the negative fifth will just give you the exponent, minus 5. Okay. So, that makes the math easy. We just take minus 5 plus 0.1761, or actually, if you'd like, let's run the minus sign through, and we'll get negative 0.1761 plus 5. Okay, and so the whole thing will come out to be 4 point, let's see, this will be 8239, something like that. You could say 4.82 will be the pH. Okay, and generally what will happen is you can always use this shortcut. You can really just take the log of the number here, okay, and then subtract that from the exponent made positive. 5 minus, what we really have here is 5 minus log of 1.5. Okay. All right. Now, what about going the other way? You'll have some problems where you will, come on here. be given the pH and need to find the hydronium concentration. Okay? So let's say your pH, let's do this in black. Let's say the pH is 6.21. Okay? All right. Now, pH is equal to this negative log of H30 plus. Okay? So let's find the H30 plus. Okay? Step 1, let's put the minus on the other side of the equation. So we have minus 6.21 is log H30 plus. Okay? And then we're just going to use, change this to exponential form. Okay? So if you remember this is a base 10, okay, think of a 10 there, 10 to, this is going to be the exponent, will equal this. Okay? So H30 plus is going to be 10 to the negative 6.21. Okay? So just plug that into your calculator using your exponent button, however, whichever type of exponent button you have. Okay? And depending on how you have your calculator set, all right, I've got mine set for digits. So 0, 0, 0, 3 zeros, 6 zeros, 6, 1, 6, 6. Okay? All right. Now, how many places do I have to move? 1, 2, 3, 4, 5, 6, 7. Okay? So that's going to be 6 point, if I round to 2 decimal places, 17 times 10 to the negative 7th. Okay? All right, and as kind of a benchmark, I've got 10 to a minus 6.1 here, 6.21. So in my answer in scientific notation, that's going to get rounded up to the next integer. Negative 7 is what I'm going to have in my final answer. Okay. All right, so that's pH. Okay. Now, pH is what's called a logarithmic scale because it has a logarithm in it. Okay. There are other places where we use logarithmic scale, and I'll bring in this graph here. Okay. This is showing total coronavirus cases in the U.S. And if you look at the graph carefully, you'll see the bottom is just showing you dates starting in February through March 24th. The side, the vertical axis, is a little different. Okay, it's going 1, 10, 100, 1,000, 10,000, 100,000 as you go up. Okay, so each grid line as you're going up is not a fixed amount of increase, it's a fixed multiple of increase. You're going up by 10, a factor of 10. 1 times 10 is 10, 10 times 10 is 100, 10 times 100 is 1,000, 10 times 1,000 is 10,000, etc. Okay? So the y scale is increasing by multiples. And if you remember from an earlier lecture, exponential functions are ones that increase by multiples. Okay? So if you look at the graph, we'll just do a little bit of estimating here. Okay? Here on March 2nd, we had about 100 cases. Okay? On March 10th, 8 days later, we had about 1,000 cases. On March, I think this is 19th, we had 10,000 cases. Okay? So we had 8 days here, 9 days here, approximately. I might be off by 1. But basically, this graph is showing us that it's a straight line, basically, in this form. Every 8 to 9 days, we have 10 times as many cases as we had before. Okay? Now, if this increases in another, say, 8 or 9 days, we're going to have 100,000 cases. Okay, and in fact, today I think we're at 80,000 cases. We might be to 100,000 tomorrow, the next day. All right, and if this trend continues, and that's a big if, um, another 9 days after that, we'll have 1 million cases. Another 9 days after that, we'll have 10 million cases. If something grows exponentially, it's going to grow by multiples, which means it will grow very quickly. Okay. Now, let's actually go ahead and do an equation for what's happening here. Okay. So, let's say we start on March 2nd. We've got 100 cases. We'll start the clock at March 2nd. Okay. Exponential functions, you can always write them as 1 plus r to the t. Okay. So we're going to let n of t be 100 times 1 plus r to the t. T is days from March 2nd. Okay. Now, what's going to happen here is, let's use 9 days. In 9 days, we're going to have 1,000 cases. Okay, so n of 9 we're estimating to be 1,000. Okay, that's going to be equal to this 100 times 1 plus r to the 9th, since we're assuming 9 days. Okay, let's solve this for r. That'll give us what we need to write the equation with the specified value of r. Okay, well, we're going to divide by 100. So 10 is going to be 1 plus r to the 9th. Okay. All right. And to solve for r, we would want to take the 9th root of both sides. Okay, so we'll go the 9th root of 1 plus r to the 9th. Okay, so on the right-hand side, we're going to get 1 plus r. And on your calculator, the 9th root of 10 is going to be about 1.29. And so, subtracting 1 from both sides, we get 0.29 as r. Okay, so what does that mean? All right, this is telling us that the number of cases in the United States is growing at about 29% per day. Every day we have 29% more cases than we had the day before. We could put that into the equation, and if we're starting from March 2nd, here would be our equation. Okay, we could use this for various values of t to predict how many cases we're going to have in the future. Okay, this would do the same thing as our multiplying by 10, only we could do this for other times other than multiples of 9 days. Okay, so that's an example of a logarithmic scale and exponential growth. Generally speaking, a logarithmic scale like this is a good way. If you see a graph that's linear in logarithmic scale like this, that's telling you this quantity is growing exponentially. All right, so that's enough for 7.4. We have one more section in this chapter that we're going to do, 7.5. I'll try to get a video for that up Friday or over the weekend, and our next test will be a week from Friday. I will be posting an outline and making some announcements about that fairly soon. So, have a good evening. We'll see you again soon.